Hello friends, I am Professor S.T. Kedari is going to teach you the subject strength of material. In that there is one topic, strain energy. So strain energy stored in body when load is applied gradually. Okay. So for that we consider a metallic bar that is subjected to gradual load. Okay, so let P is nothing but a load applied gradually. A is a cross-sectional area of the bar, L is the length of bar, E is a modulus of elasticity, and del the deformation of the bar due to load. Since the load is applied gradually and varies from 0 to P, therefore the average load is equal to P by 2. So the work done is equal to force into distance, with nothing but a average load into deformation. So average load we taken as P by 2 into delta L. So P by 2 into E into L, as strain is nothing but a change in length upon original length. So we take another value of P by 2 is nothing but a stress is equal to force, means load upon area. So put this value in this equation, we get 1 by 2 sigma into E into A into L is nothing but a 1 by 2. This one is a stress, strain, and A into L is a volume. So we get 1 by 2 stress, and we put the value of strain is as per the Hooke's law of elasticity, sigma upon E into A into L. So 1 by 2, this becomes sigma square upon E into A into L. So we get sigma square upon 2E A into L. So we get E is equal to U is equal to sigma square upon 2E into V, where V is a volume and its value is A into L. Since the energy stored is equal to work done, strain energy stored, U is equal to sigma square upon 2E into V. Modulus of resilience is equal to strain energy per unit volume, which is equal to sigma square upon 2E. Similarly, strain energy stored in body due to sudden applied load. For that purpose, we consider a bar subjected to sudden load. Let P is equal to load applied suddenly, is a cross-sectional area of the bar, is modulus of elasticity of the material, L is the length of bar, and delta is the deformation of the bar, sigma stress induced by the application of sudden load. Since the load is applied suddenly, therefore the load P is constant throughout the process of deformation of the bar. And again we take work done is equal to force into distance, where it is average load into deformation. So force is P into delta L. We know that the strain energy stored is U is equal to sigma square 2E upon L. Since the energy stored is equal to work done, therefore sigma square upon 2E AL is equal to P into delta L. So we get sigma square 2E upon 2E into AL is equal to P. We put the value of delta L, sigma upon E into L, as per this. Sigma is equal to therefore sigma is equal to 2P upon A. It means that the stress induced in this case is twice the stress induced when the same load is applied gradually. Once the stress is obtained, the corresponding instantaneous deformation delta L and the strain energy may be found out as usual. Hence, for gradually applied load, sigma is equal to P upon A, and for suddenly applied load, sigma is equal to 2P upon A.